In this video I'm going to show you how we find the magnetic field lines around the magnet. I also will show you how we find the direction of the magnetic field around the magnet. When we move a compass around the magnet, you will see that the red pointer of the compass is constantly changing. This tells us a lot about the direction of the magnetic field. In this video I will show you how we first find the shape of the magnetic field lines around the magnet, and I will show you how we find the direction of the magnetic field lines. In order to find the shape of the magnetic field around the magnet bar, I'm going to use iron filings, small particles of iron. I placed a magnet under the paper and then I'm slowly going to spread out the iron filings. Let's have a look. We see clearly the lines around the pole and the shape of the magnetic field. Now we are going to draw the field lines around the magnets, and then we will use a compass to find the direction of the magnetic field. In the second phase, now that we have drawn more or less the field lines, we can find now the direction of the field, and we use the red pointer of the magnet. And the red pointer of the magnet tells us what is the direction of the magnetic field line. So the field lines are directed with the red pointer. Let's have a look. And we can see clearly that the field lines are going out of the North Pole into the South Pole. Question: what do you think? What is the direction of the field lines inside the magnet? Now we're going to look at three situations wherein we place two magnet bars together. The first assignment that I want you to do is we place the South Pole on one side, the North Pole on one side, and try to draw the magnetic fields. In the second assignment, I want you to draw the field lines when we have a North Pole on one side and a North Pole on the other side. In the third assignment, I want you to draw the magnetic field lines when we have the South Pole on one side and the South Pole on the other side. And we can see the field lines between the North Pole and the South Pole. Again, look very good at the shape of the lines. Okay, let's draw the magnetic field lines. Now we're going to look at the field lines from north to north. Now we draw the field lines from south to south. So, in review, in order to find the magnetic field around a bar magnet, we can make use of iron filings. The iron filings tell us the shape of the magnetic field lines. Secondly, we use a compass to find the direction of the magnetic field lines. And we can use different situations of magnets to find magnetic field lines between north and south, south and south, north and north. Important to note is that the magnetic field lines are always going outside the North Pole, inside the South Pole. Another point to note, if you have been looking very good at the pictures, the video, you will see more lines, a higher density of lines near the poles. You see clearly that there are more filings concentrated and more lines concentrated near the poles. This will tell us a little bit about the magnetic strength. In order to measure the magnetic field strength, I'm going to use an app that measures the magnetic field strength. The measurements are in microtesla, and let's see what is going to happen with the values when I place a magnet closer to the app. Now I'm going to move a magnet closer, and we see that it values goes way up. Now I use the other pole, and we see that it goes very much up. The magnetic field strength is the strongest closest at the poles. When we move away, it decreases. When we go close, it increases.